Okay, hello guys. So today we will go through assignment 4, okay, or tutorial 4. So basically for tutorial 4 what we are looking at is a closed system, okay, that consists of your water, steam, or anything that's related to H2O. Okay, so let's look at the first question. A rigid vessel of volume 2.6 meter cube consisting of dry saturated steam at 15 bar is cooled at a constant volume until its pressure becomes 6 bar. Okay, determine the following. So for this particular question, clearly it is a constant volume process. Okay, so you must bear in mind what does this indicate? Okay, because it is a constant volume process, so there's no change in volume, so there is no work done. Okay, so for part A, so to get the mass of the system, since we already have the volume, okay, what we need is actually the specific volume. Okay, so today, since it's a dry saturated steam at 15 bar, okay, so the specific volume, okay, will be equals to the Vg at 15 bar. Okay, so from our table, Vg at 15 bar we will get 0.1317 meter cube per kg. Okay, so after we know our specific volume of the initial state, we can get the mass, which will be V over V. Okay, so this will be 2.6 divided by 0.1317, and this will give us our 19.74 kg. Alright, so this is for the first part. Okay, B. Okay, find the final dryness fraction of the steam. Okay, so for part B, it gives us a clue that the final state is actually wet. Okay, because usually when there's dryness fraction, it's associated with wet steam. So we are required to find the dryness fraction of this wet steam. Okay, so first and foremost, okay, since it is a constant volume process, so we can clearly say that V2 must be equals to V1, which is equals to 0.1317 meter cube per kg. Okay, so this is the first thing that we can establish. Next, we need the reference specific volume, and in this case the final state is at 6 bar. Okay, so from the table we can find out what is Vg at 6 bar. Also from the saturated water and steam table, Vg at 6 bar is given to be 0.3156 meter cube per kg. So after we know these two values, our so-called dryness fraction will be V2 over Vg. Okay, 0.1317 divided by 0.3156. Okay, so this will give us our 0.4173. Okay, so pretty standard. Okay, next we have C. Okay, find the change of internal energy during the process. Okay, so to get the change of internal energy, we need the initial internal energy and the final internal energy. Okay, so for the initial internal energy, U1, or the initial specific internal energy, U1, this is equivalent to Ug at 15 bar because it is dry saturated steam. Okay, so from the table we will get 2595 kilojoule per kg. Okay, and for U2, okay, to get the specific internal energy of U2, we need to use our formula for wet steam, 1 minus x UF plus x Ug. Okay, so 1 minus 0.4173. So for this UF, this is found from UF at 6 bar. Okay, so we go to the table, UF at 6 bar. Okay, and we can get a value of 669 plus Ug at also 6 bar, which we can get to be 2568. Okay, so once we get this full set of equation, we can plug in and find the 1461.453 kilojoule per kg. Okay, so the total change in energy will be U1 minus U2. Okay, can. So in this case, U2 minus U1. U2 minus U1. So we need to multiply by the mass of specific U2 minus specific U1. Okay, so this will be 19.74 multiplied by 1461.453 minus away 2595, and this will give us our delta U, which is negative 22376.3 kilojoule. Okay, so this is our part C. Part D, to find the work energy. So since it's a constant volume process, so work must be 0. That's it. Okay, so for the heat energy transferred, okay, we need to write down the non-flow equation. U2 minus U1 is equals to Q minus W. Since W is 0, so we can safely say that Q is U2 minus U1, which will be negative 22376.3 kilojoule, negative value. Alright, okay, so this will be our heat. So the last part, sketch the above process on a PV diagram. Okay, sketch the above process on a PV diagram. Get another piece of paper. Okay, so how do we sketch the above process in a PV diagram? So first of all, let us just draw the so-called bell curve. Okay, so since initial stage is at 15 bar, okay, so we mark out 15 bar, and it is dry saturated steam, so it should be on this half of the curve, exactly lying on this line. Okay, and we know that this specific volume is 0.1317. Okay, so since it's a constant volume process, it will be a vertical line, okay, until it goes up to 6 bar. So this is stage 1, this is stage 2. Okay, so this is pressure in terms of bar, and this is specific volume in terms of meter cube per kg. Alright, so this is the final answer for part F. Okay, good. Okay, so next question 2. Okay, question 2. We have again a closed system, 12.5 kg of superheated steam at a pressure of 20 bar and a temperature of 400 degrees Celsius is cooled at constant volume until the pressure becomes 12 bar. So again, it's a constant volume process. Okay, can. So first, part A, find the dryness fraction of the steam. Okay, in this case, it's referring to the final state. Correct. Okay, because the initial state is superheated. So since they are asking for the dryness fraction of the steam, it must be related to the final state. Okay, so how do we get the dryness fraction? Okay, we need the specific volume. So firstly, okay, because the specific volume V2 in this case will be equals to V1 since it's a constant volume process. And how do we get the specific volume of V1? It is actually the specific volume of superheated steam, right? Superheated steam at 20 bar and 400 degrees Celsius. Okay, so we will go to the superheater table to find out this V value. Okay, so since this will be 0.1511 meter cube per kg. Okay. So next, to get the reference temperature, which is Vg at 12 bar, because the final state is 12 bar. So from the saturated water and steam table, Vg at 12 bar will be 0.1632 meter cube per kg. So what is your dryness fraction? It will be V2 over Vg. So 0.1511 divided by 0.1632, and this will give us a value of 0.9259. Alright. B. The change in internal energy during the process. So same thing, we need both U1 and U2. Okay. So for the specific volume of a specific internal energy of 1, this will be equals to the U of superheated, right? Again at 20 bar and 400. Okay. So we go to the superheated table and we'll get the value of 2946 kilojoule per kg. U2, because it is a wet steam, so again wet steam formula. Okay, so 1 minus 0.9259. The UF will be UF at 12 bar. Alright, so the UF at 12 bar from the saturated water and steam table, you'll get 797 plus 0.9259. Okay, multiply by the UG also at 12 bar, which is 2588. So calculate this value, you will get 2455.287. Alright. So to get the full change in internal energy, U2 minus U1, again multiply by mass. So the mass in this case is 12.5 kg. Okay, multiply by our U2 minus U1, and this will give us our minus 6133.88 kilojoule. Alright. C, since again constant volume process, work done will be 0. Heat, U2 minus U1 is equals to Q minus W. So W is 0. So Q will be U2 minus U1, which will give us back our negative 6133.88 kilojoule. Alright. And again, we are asked to sketch the diagram. Okay, so draw your curve again. Okay, so initial is a superheated steam at 20 bar, so it should be somewhere here outside. Okay, the specific volume is 0.1511. So again, it will be a vertical line all the way down to here, which is 12 bar. Okay. Okay. So this will be our final PV diagram. It's the process. Okay, next for question number 3. Okay, we have a closed system, 1.25 meter cube of wet steam at a pressure of 8 bar and a dryness fraction of 0.75 is heated at constant pressure until it becomes dry saturated steam. So this is a constant pressure process. Okay. We are asked to determine the mass of the steam. Okay. So to get the mass of the steam, okay, we have the volume, so we need the specific volume of stage 1. Okay, so the specific volume of stage 1, okay, since it's a wet steam, right, so you'll follow the formula XVG. Okay, and this VG is obtained from 8 bar lah. Okay, so this will be 0.75 multiplied by 0.2403. Okay, this is from the table, 0.243. And this value here you will get 0.18023 meter cube per kg. Okay, so this is our V1. So to get the mass, again V over V. So this is 1.25 divided by 0.18023. Okay, this will give us our 6.936 kg. Okay, part B. Find the change in internal energy, work done, and heat energy transferred. So firstly, we get the change in internal energy. So we need both U1 and U2. So for U1, or specific internal energy of stage 1, we will use the formula 1 minus x UF plus x UG. Okay, so 1 minus 0.75. UF again is UF at 8 bar. So UF at 8 bar you will get 720 plus 0.75 times UG also at 8 bar. So this will be 2577. Okay, so this total value up will give you 22112.75. Okay, next to get the U2, because it is a dry saturated steam, right, given by the question, dry saturated steam. So U2 will simply be UG at 8 bar. Okay, why 8 bar? Because it's a constant pressure process. So initially, if 8 bar, final will also be 8 bar. So this value here from the table, you'll get 2577. Okay, so U2 minus U1 will be mass times small u2 minus u1. So 6.936 multiplied by 2577 minus away our 22112.75. Okay, and this value here you will give us our 3220 kilojoule. Okay. I think this value here there's some mistake. Let me just give me a minute. Okay, it should be 2112. So don't have this value. Okay, so this is our big U2 minus U1. Okay, next to get the work done, since it's a constant pressure process, okay, the work done there's a specific formula to use, which is MP, okay, V2 minus V1. So in this case, the mass is 6.936. The pressure is 8 bar, right? So 8 times 10 to the power of 5, right? Change to Pascal. V2. Okay, so for V2, right, where do we get the V2? V2, since it's a dry saturated steam, this V2 will be equivalent to VG at 8 bar. Okay. So for VG at 8 bar from the saturated water and steam table, okay, you will get 0.2403. Okay, minus away our V1, which we calculated. Okay, so this value here, we will get in terms of joule. This value we will get in terms of joule, because all what we plug in here is all in SI unit. So it should be 333,300 joule lah. So you convert to kilojoule, this will be 333.3 kilojoule. Okay, the numbers might not be exact, but it doesn't matter lah. Oh, just a few decimal place difference, it doesn't matter. Okay, so next for the heat energy transferred. So to get the heat energy transferred, very simple. We'll use our non-flow equation. U2 minus U1 is equals to Q minus W. So U2 minus U1 is 3220. Q is 333.3 minus W. So at the end of the day, W you will get 3553.3 kilojoule. Okay. So finally, we will sketch the PV diagram. Okay, so again, draw your bell curve. So everything will happen at 8 bar. Okay, initially it's wet steam, so it must be somewhere inside here. Okay, V1 is 0.18023. Okay, then it will go to superheated. Oh sorry, just dry saturated. It will go to here. So this is 1, this is 2. Okay. And plug in your this one. This is our VG at A bar, which is 0.2403. Okay. Okay. So this is your constant pressure line, which is a horizontal line. So please don't confuse yourself. For constant volume is vertical line, constant pressure is horizontal line. No, as the name implies, constant volume and constant pressure. So you should go accordingly. Okay, question number 4. Okay, question number 4. Okay, so we have a closed system, 0.25 meter cube of superheated steam at a pressure of 10 bar and a temperature of 300 degrees Celsius. Cools at a constant pressure until the volume becomes 0.15. So this is again a constant pressure process. Okay, constant pressure process. So part A, to get the mass of the steam, since we have the total volume, we need the specific volume as stage 1. So the specific volume as stage 1, in this case, because stage 1 is superheated steam at 10 bar and 200 degrees Celsius, this will be V of superheated at 10 bar and 300. Okay, so again we go to the table, we look for it, we will get 0.2580. Alright. So after we get our V1, our mass will be V over V. Okay, so this is our mass. Part B, the dryness fraction of the steam after cooling. Okay, so in this case, after cooling, right, the steam actually becomes wet steam. Okay, so we will need both the specific volume of this second stage and also the reference VG. Okay, in this case the